Okay, we are going to go over parallel and perpendicular equations, specifically their slopes. Now, in the review portion, you should have done an activity where you had a bunch of lines and you tried to figure out which ones looked parallel, which ones looked perpendicular, and features about them that might clue you into a definition. Hopefully the definition you came up with was that two lines are parallel if they have the same slope. And I want you to put parallel and same slope in the same color. So when you look at this page, you can see parallel, same slope right away. Now, how are we going to use this? Well, if we're given a question like this, which two lines are parallel and how do you know? They all kind of look parallel, right? But in order to know for sure, we need to find the slope of each one. So we can say, well, this one's parallel to this one, or this one to this one. Maybe they're all parallel. We're not sure. So let's label these A, B, and C. In your book, they're going to be colored lines, red, green, and blue, but for now we'll just label them A, B, and C. Okay. First, we're going to find the slope of line A. So here's line A. My slope formula, y2 minus y1 over x2 minus x1. Okay. And I have my 2 points here. So this is my x1, y1, x2, y2. So I put that in my formula. I get negative 2 minus 2 over negative 4 minus negative 3. Be careful here because I'm subtracting a negative number. When I reduce this, negative 2 minus 2 is negative 4. Negative 4 minus negative 3 is negative 4 plus 3, which is negative 1, which means that the slope for line A is a positive 4. Now I want you to do the same thing. You're going to do it for B and C, and we'll figure out which of these lines are parallel or if they're all parallel. So pause the video, you can do that, and when you come back I'll go over the answers to make sure that we're all on the same page. Okay, let's go over the slope for B and C. Now I'm not going to rewrite this formula here, I'm just going to show my work because I have the formula right here. It doesn't make sense to keep writing it down. For line B, I have an x1 and a y1, an x2 and a y2. That means when I fill these in, I'm going to have negative 2 minus 3, negative 2 minus 3 over 0 minus 1. 0 minus 1. If you can't notice that this is a negative symbol, that's a negative symbol. Okay, just to make sure you can see that clear on the paper. Keep simplifying. Negative 2 minus 3 is negative 5. 0 minus 1 is negative 1. So the slope for this one is a positive 5. And for C, we've got an x1, y1, x2, y2. So when we put that into our slope formula, we're going to have negative 3 minus 1 over, right, that's y2 minus y1, over 3 minus 4. reduce that. Negative 3 minus 1 is negative 4. 3 minus 4 is negative 1. Negatives cancel out, so we have a positive 4, which means that line A and line C are parallel. So while B looks like it's parallel to either A or C, these ones are in fact the ones that are parallel. Okay? And parallel means that they will never touch. Now, some of you might be wondering, well, I have these graphs here, and yes, I have the points, and yes, I can use my formula, but wouldn't it be easier to just count? And the answer is yes, it would absolutely be easier to count. The reason I did it this way is so you get more practice with using the slope formula. But if we count up 1, up 2, up 3, up 4, right, when we go up, it's a positive direction, 4. And then our run is positive 1. So the slope here is going to be 4 over 1, which is 4. Okay, to the right and up. Both of those are positive movements. Now, I'm not going to do line B, but take a look at line C. We know that these two lines are parallel. So if I go up 4 and over 1 here, I should have to go up 4 and over 1 on this one. Okay, I like to think of it as two people kind of walking in a line. Okay, parallel means they're never going to touch. If this person goes up 4 spaces, this person's going to go up 4 spaces. If he goes to the right one, he's going to go to the right one. And if they have these same movements every time, they're never going to meet each other. If this one goes up, say, 3, and this one goes up 5, and this one goes across 7, and this one goes across 2, eventually they're going to meet, because they're not walking the same direction each time. So that's how I think of parallel slopes. So when you do this one goes up 1, 2, 3, 4, just like we predicted, and the run is a positive 1, which means that the slope of line C is also 4. Okay. So the answer to this whole problem is lines A and C. Okay. And how do we know? They have the same slope. Alright, you're going to go down a line, and we're going to talk now about perpendicular lines. So in the review, right, you went over parallel lines, found a pattern. There's also a pattern for perpendicular lines. Okay, the vocabulary that you're supposed to use on the review sheet is kind of a hard one to remember because it's a definition all the way back from 6th grade. So we're going to briefly go over that too. So the definition of lines that are perpendicular, okay, two lines are perpendicular if their slopes are negative reciprocals. Okay, negative reciprocals. Negative reciprocals are two numbers, okay, whose numerator and denominator are switched and who have opposite signs. So for example, and I did this in orange, okay, just drew an arrow down. It's an example of a negative reciprocal. If you have negative 3/4 and you're trying to find the negative reciprocal of that, well, we're going to change the sign and we're going to flip the numerator and the denominator. So it becomes a positive 4/3. So you see how one's negative, one's positive. Okay. If this was positive, then this would be negative, because we changed the sign. But these are negative reciprocals. And if we got these two as slopes, if one slope was negative 3/4 and the other was positive 4/3, then those two lines would be perpendicular to each other. So now we're presented with 3 lines, and we're asked which 2 lines are perpendicular. And how do we know? Okay. Well, let's label this one A. We'll label this one B, and we'll label this one C. Now I know B and C are not going to be perpendicular to each other. They might actually be parallel. Kind of look like it. Okay, but A is either going to be perpendicular to B, or A is going to be perpendicular to C. So what I would do if I was approached with this problem is I would find A first, okay, just to shorten the work. So let's find the slope of line A. Slope formula is y2 minus y1 over x2 minus x1. And you could count here, okay, but it's very tricky because there's a lot of intersections and I don't want to make a mistake. So I'm not going to count, I'm going to use the slope formula. Okay. So for A, looks like my point is 0, 5, that's my x1, y1, and negative 2, negative 2, that's my x2, y2. And when I put that into my slope formula, that's negative 2 minus 5 over negative 2 minus 0. Now negative 2 minus 5 is negative 7. Negative 2 minus 0 is negative 2. So my slope is negative 7 over negative 2. But really, we have 2 negatives here. Okay? These 2 negatives are going to cancel out. So my slope is positive 7 over 2. Which makes sense because if you look at Joe, right? Joe is walking up as he goes to the right. Remember Joe's disease, he always has to walk to the right, and he's going up. Now you try and do B and C, and we'll figure out which 2 lines are parallel. So I'll let you pause the video now. When you come back, we'll go over the answer. We're going to do line B. Okay. So I've got my x1, y1, x2, y2. And I have my slope formula here, so I'm not going to rewrite it. It's y2 minus y1. That's 4 minus 6 over x2 minus x1. That's 1 minus negative 5. Keep simplifying. 4 minus 6 is negative 2. 1 minus negative 5. That's really 1 plus 5, which brings us to 6. Now I can reduce negative 2 over 6. Okay, they're both even, so I know 2 goes into both. So that means negative 2 divided by 2, that's going to be negative 1 over 3. So the slope for line B is negative 1/3, which is not the reciprocal to 7/2. Right? The negative reciprocal we're looking for is going to be negative 2 over 7. Right? Flip the numerator and the denominator, okay, and then change the sign. So hopefully it's C, or if we did something wrong. Let's label our lines, our points, x1, y1, x2, y2. I have my slope formula over here, so that's y2 minus y1, which is negative 2 minus 0, over x2 minus x1, which is going to be 2 minus negative 5. Simplifying, I get negative 2 minus 0 is negative 2 over 2 minus negative 5. So that's really 2 plus 5, which is 7. So the slope for line C is going to be negative 2/7. So it looks like it's, again, lines A and C, right? Okay. And how do we know? The slopes are negative reciprocals. Alright, so that's all you need to know for parallel and perpendicular equations. Your practice is going to be from the workbook, and it's going to be finding the slope between lines and looking at equations. Please let your teacher know that you are now done with the notes portion so you can move on to the practice portion.